The curl of the vector A equal to zi vector plus xj vector plus yk vector is the curl of a vector f is yi vector. Identify the appropriate vector field f. Identify the nature of the vector field v vector equal to x squared y I vector minus 2yz j vector plus 3e to the power z k vector. Stokes' theorem relates the value of integral x cube into dy dz plus y cube into dz dx plus z cube into dx dy over the surface of the sphere x squared plus y squared plus z squared is equal to a squared is. Find the curl of the vector A. Solution. Curl of a vector is written as del cross A, which is in the matrix form. The first row is unit vectors I, j, k, and the second row is derivative operators dou by dou x, dou by dou y, and dou by dou z. In the third row, we have to write the components of I, j, k, that is z, x, and y, which is equal to I into dou y by dou y minus dou x by dou z minus j into dou y by dou x minus dou z by dou z plus k into dou x by dou x minus dou z by dou y, which is equal to I vector into dou y by dou y is 1 and dou x by dou z is 0. So 1 minus 0 minus j vector into 0 minus 1 plus k vector into 1 minus 0. Therefore, del cross A equal to I vector plus j vector plus k vector. Therefore, the answer is option A. 12th problem. Given del cross F is equal to y into I vector. Find F vector. To find the F vector, we have to take the options one by one. It will take only less amount of time. First, let us take the option A. F is equal to x squared I vector minus yz j vector plus zk vector. Del cross F is equal to matrix of I, j, k, dou by dou x, dou by dou y, dou by dou z. Third row, x squared minus yz z, which is equal to I vector into dou z by dou y minus dou by dou z of minus yz minus j vector into dou z by dou x minus dou by dou z of x squared plus k vector into dou by dou x of minus yz minus dou by dou y of x squared, which is equal to I vector into dou z by dou y is 0, and in the second term take minus y outside, so minus into minus plus y into dou z by dou z is 1 minus j vector into 0 minus 0 plus k vector into 0 minus 0. Therefore, del cross F is equal to y into I vector. Here, in this problem, the option A is the correct one. If not means, we have to take option B, then C, and then D. 13th one. In this problem, we have to find the nature of the given vector V. The first condition, if a vector is said to be solenoidal, then del dot V is equal to 0. Second condition, if a vector is irrotational, then del cross V is equal to 0. Let us check the first condition, del dot V vector. Del value is dou by dou x into I vector plus dou by dou y into j vector plus dou by dou z into k vector. Dot V value is x squared y into I vector minus 2yz into j vector plus 3 e to the power z into k vector. We know that I dot I is equal to 1 and I dot j and I dot k which is equal to 0. Therefore, del dot v vector is equal to dou by dou x of x squared y minus dou by dou y of 2yz plus dou by dou z of 3 e to the power z. In the first term, let us take y outside. If we differentiate x squared means we get 2x. In the second term, let us take 2z outside and dou y by dou y is 1. In the third term, we have to differentiate e to the power z means the differentiation value is also e to the power z. So we get 2xy minus 2z plus 3 into e to the power z, which is not equal to 0. So the vector v is not solenoidal. Now let us check the second condition. Del cross v vector is equal to matrix of I vector, j vector, k vector, dou by dou x, dou by dou y, dou by dou z. Third row, x squared y minus 2yz 3 e to the power z, which is equal to I into dou by dou y of 3 e to the power z minus dou by dou z of minus 2yz minus j vector into dou by dou x of 3 e to the power z minus dou by dou z of x squared y plus k vector into dou by dou x of minus 2yz minus dou by dou y of x squared y, which is equal to I vector into 0 plus 2y minus j vector into 0 minus 0 plus k vector into 0 minus x squared. Therefore, del cross v vector is equal to 2y into I vector minus x squared into k vector, which is also not equal to 0. So the vector v is not irrotational. Hence, the answer is option C. Stokes' theorem is integral over L f dot dl equal to integral over S del cross f into ds. This implies Stokes' theorem relates line integral and surface integral. 15th problem. Integral over the surface of x cube dy dz plus y cube dz dx plus z cube dx dy is given that x squared plus y squared plus z squared is equal to a squared. Solution. Here let us use divergence theorem. Integral over the surface of f dot unit vector n into ds, which is equal to integral over the volume div f vector into dv. Differentiate the term, we get 3x squared plus 3y squared plus 3z squared into dv. Let us we take 3 outside. So which is equal to 3 into integral over the volume of x squared plus y squared plus z squared into dv, which is equal to, the value x squared plus y squared plus z squared is a squared, and integral over the volume dv, which is equal to v. So we get 3a squared into v. Volume of the sphere v is 4 by 3 pi a cube. Substitute the values. Finally we get 4 pi a to the power 5. Thank you.